Okay, first one, what is network? Network means interconnections, so interconnection of the two or more simple circuit elements. So two or more simple circuits. Okay, you will go to interconnection of two or more simple circuit element. What is the element, or another name it is called as a device? Resistance, inductance, capacitance. So these are the element you can call, or devices you can call interconnections. So you will go to interconnected. How to interconnected? See, I'm using one inductance and the resistance. So I'm using on that one. Okay, here is I will going to use the power supply. I will going to use the power supply. Okay, power supply I will going to use. See, this is the interconnections. So this is the interconnection of that elements or devices. Okay, further I will going to extend it. Further I will going to extend the circuits. Okay, see, here is a, what is the source? It's a AC source. AC symbol is mentioned. This is the AC symbol. This is the inductance is mentioned. So when inductance is coming, means mostly it is coming on that one AC source. When you whenever you will going to draw the AC source, inductance it will going to come. So DC source means you will going to denote it for that one lengthy line and one small line. Lengthy line denoted for that plus. Always you should write here plus and minus. Okay, plus and minus. It's a DC source. Okay, this is a DC source. Okay, source. Then followed by that two or more simple circuit element. Okay, element you will going to connect it. So I'm going to connect it for one resistance here. So resistance. Okay, here I will going to connect it one resistance. Okay, I will going to connect it, and I will going to further I will going to connect it the resistance. So this is about interconnections. So interconnection of that one, see, 1 2 3. Okay, 3 element is interconnected. This is a one element, this is another element, this 2 element is interconnected. So like I will going to create the circuit, I will going to create the simple circuit. I will going to create, if I will going to create it on the simple circuit, it is called as a network. Okay, your circuit may be open circuit. This is, see, here is a open circuit, or you will going to make two closed circuits. So open network or closed network, it is called open network or closed network you will going to create. Okay, the next one we will go ahead on that one more basic term about the circuit. What is meaning of circuit? Circuit is nothing but at least one closed part. Okay, circuit is, what is circuit? The network. This is total circuit is network. Okay, this network contain an at least one closed path. See how many closed path in that circuit? There is two closed path in the circuit. 1 2. So here is one more. I will going to open. See, open means, see, resistance is there. Here is a open. I'm not closed about this this one. So it's a open circuit. But this is called a circuit or not? Yes, it is called as a circuit. How do you say it is called as a circuit? Means at least one closed path is there. See, here is more than one closed path is there. So that's why it is called as a circuit. The network contain at least one closed path, means that is called a circuit. Fine. The next we go ahead on the current. What is a current? Current means flow of the electron. Flow of the electron or charges you can call it as a current. Okay, in a conductor. What is a conductor? Conductor is nothing but a cable or a conducting media. Anything. Okay, in the media you can say whatever that one. Okay, in that one flow of that one. See, wire is there. Okay, wire. In the wire is a current is a flow. Okay, current is a flow. What is when the current is a flow? Okay, when the circuit is a closed circuit, the current is a flow. So you will going to form on that one closed circuit. See, do I want to close? Yes, it is a closed. Current, what will happen? It is a closed. Okay, current is a flow only in closed part. So, but what happened? Yeah, I will going to make the short circuited. So instead of short circuited, I will going to connect one lamp here. So if it is my lamp is connected here, what will happen? Okay, what will happen? Okay, the lamp, through the lamp, the circuit is closed. Through the lamp, the circuit is closed. When the current is a flow, the circuit is a closed circuit. The current is a flow. Keep in your mind. Okay, when the current is a flow, the circuit is closed. So these are some basic terms I will going to teach you. This is a lamp. What is a lamp? You can, in electrical term, it is called incandescent lamp. Incandescent lamp, about that one. Incandescent lamp, you can simply call it as a bulb. You will going to call it as about the bulb. This bulb, what is the speciality about that one? They will going to give the rating. Okay, 230 voltage. Okay, and with respect to the watt value, they will going to give. What is the watt range? 40 watt, 60 watt, 100 watt. Okay, normally what we are going to suggest in that one, don't use the incandescent lamp. Why don't use the incandescent lamp? Means it's a power consumption is more, and it will going to emit that heat. It will going to emit the heat, and it will going to affect the environment. So that's why power consumption is more. So instead of that, using this incandescent lamp, go to the LED lamp or CFL bulb you will going to use. That one is suggested by the electrical engineering, that one all over in world. Okay, coming to the point. Okay, so incandescent lamp is used. So when the current is a flow, the circuit is closed. Okay, in a conductor, the flow of the charge in a conductor, when the flow of the charge in a conductor, the circuit is closed, then only the flow of the charge in a conductor. Okay, so that is denoted q with respect to the time. So q with respect to the time, that is called current. Okay, then what is the voltage? Okay, we going to see about the voltage. So potential difference between these 2 points, here and here. Do I have connected any switch? No switches I have used here. So between here you will going to use one voltmeter. That is one voltmeter. How to use the voltmeter? So across 2 point, across the 2 point, voltmeter is connected. I will change the color. Okay, voltmeter I will going to use across the 2 point. Okay, suppose the bulb, okay, it will going to get the fused. Fuse means the tungsten is open. The tungsten is open. Even though tungsten is open, if I have see the voltmeter, that's voltmeter it will going to reflect the value, means yes, the voltmeter will going to show the value. Why? Why means it's a 2 point. Okay, between the 2 point, the voltmeter is connected. Voltmeter is connected between 2 point. Okay, that's all. Even the tungsten is open. Okay, between the 2 point, the voltmeter is connected. Even, okay, here is no switches there. So this is a point. See, current is coming from this point to this, up to this, and up to this point it is coming. Even the tungsten is open. When you will going to touch here, here is a human. Okay, he will go. Okay, human is touching here means you feel the shock. Why you feel the shock? Because the current is coming up to this point. Okay, so this is about the voltmeter. Okay, potential difference between 2 point. What is ammeter? Ammeter always connected in series. Okay, series with the load. Here is a red color I will going to denote it. This is called ammeter. So ammeter is what is used. You will going to connect it in series with the load to see the amps rating, flow of the amps. Fine. So this is about that one energy. So morning I will going to, my energy is morning more, so my work done is more. Okay, my capacity of doing my work, so energy is denoted for that. What is the capacity of doing my work? Okay, so morning my capacity is more, so my output power is more. Okay, I will going to give a effective performance on the morning, so because my energy is more, so this energy and power is correlated. So capacity for doing the work is called energy. What is the power? Energy with respect to the time. Morning my power is more, output power is more. Afternoon my energy is less, my output power is less. So this is about power. The power is a ratio of the energy to time. So charge to time is called current. Energy to time is called power. Okay, that's all. This is some basic terms. Let's we move it on that one. Elements. This element, basic the element is there. That element, what are the three elements? Means resistance, inductance, and capacitance. So this three basic element is there. Okay, this three element is used for that your circuit. Okay, let's we go ahead on that one. This element. Okay, resistance. What is the resistance? Resistance means normally oppose the flow of the current. So that general phenomena is what is the general work is it will going to oppose the flow of current. See here, I saw about this circuit lamp. Okay, incandescent lamp. In the incandescent lamp, okay, and directly connected to the power supply, it's a lamp is glowing. Even you will going to connect one multimeter, okay, across the lamp. Before you will going to connect the power supply, use that one, the lamp across, you will going to connect one multimeter. In the multimeter having the ohm, okay, resistance point available. So check the resistance value. The multimeter will going to show about you for 200 amps, sorry, 200 ohm, around 200 or 150 ohm across the lamp. It will show you what is the meaning. It is shows okay, it has the resistance. The lamp, it has the resistance. The resistance value is less. Okay, it is a flow of current is more. The more good brightness. If resistance value is increase, means what will happen? Your flow of current is minimized. You will going to reduce the flow of current. Okay, one more example I will tell you about that one. Fan regulator. Do you see the fan regulator in electrical fan regulator or electronics fan regulator? Small size also came. Okay, in olden days we are using one box size. It is a electrical fan regulator. What is there inside the fan regulator? Means resistance is there. When the position number 1, the resistance value is very high. That's why the speed is very less. When position number 5 is, the resistance value is very less. That's why the flow of current is more. The fan speed is high. That's all. So this is about the resistance. Okay, Ohm's law. Already you have studied about Ohm's law, basic terms about the Ohm's law. It is saying about you always keep in your mind, always Ohm's law V is equal to I into R. So that is a Ohm's law. From that one equation V is equal to I into R. Okay, so you may say about I value, you may say about R value. If it is R means keep it R one side, I you can move opposite side, V by I. So this is about R equation. If you want to, you need only I only right hand side. So keep it on I on that one. Okay, another side is what is there? V is there. Okay, V divided by R. So this is a R. Okay, you will go to write. So what is it to say? R and resistance and current is inversely proportional. Resistance and current is inversely proportional. Inversely proportional means what? If current values increase, if the current values increase, the resistance values decrease. If current values increase means what? Okay, current values maximum. Current values maximum, or it is called infinity. If current value is infinity, what is the resistance value? 0. So 0. When the current value is maximum, when the circuit is closed circuit, when the circuit is closed circuit, see the circuit is closed. If the circuit is closed means current is a flow. Current is a flow. If the circuit is open means tungsten is open means current is not flow. So when the circuit is closed, full amps current is a flow, infinity. Resistance value is 0. When the circuit is lamp is tungsten is open, the current value is 0. Current value is 0. If current value is 0 means resistance values increase. Okay. So that one I have shows you one more slide. Where is that one point? Yes. So here I have to show you. This is a open circuit. This is a closed circuit. If it is a open circuit means what? The current value is 0. Resistance value is infinity. Current value is maximum. When it is maximum, if the circuit is closed, okay, through that one, okay, through the lamp or resistance used to, you will go to close. You see this one, this is called short circuited. So source is directly shorted. Normally for understanding purpose I am showing you, but what we will going to do, you will going to connect it with one lamp or resistance. Okay, if you will going to close the circuit, current is the maximum value, resistance value is 0. Fine. Then next what we want to see, yeah, okay, so yeah, this is about resistance, unit is a ohm, and inverse of resistance is called conductance. Okay, one more question, what is the inverse of the resistance? You should say about the conductance. What is the unit of the conductance? Yeah, mho. Okay, there see just opposite symbol. The next one is inductance and capacitance. So equation about inductance and capacitance, easy to remember about that one. Here I have show you the inductance and the capacitance of the equations. There is a two term, one is a voltage term, another one is a current term. So there is a two term. Okay, one is a voltage, another one is current. First one we are about the resistance. So resistance V is equal to IR, I is equal to V by R, this one you know. Then power, what is the power? P is equal to V into I. Okay, this is the power equations. Okay, here is a, okay, this V, I will going to put the circle. Why? Substitute the I into R in the place. So I into R you will going to substitute. So V is replaced into I into R. So I R. So if it is I into R means I squared into R. Okay, I squared into. Okay, so that is about P is equal to V into I, V value substituted, so I into I, so I squared into R. So next one, okay, about the inductance, about the capacitance. So inductance is the unit is Henry, capacitance unit is a farad. Okay, fine. Then Henry inductance. So V is equal to L dot. Okay, what is a V is written another term I. So di by dt. So changes of the current with respect to the time. So this is about voltage equation. So easy to you will going to remember. Similarly capacitance. So the capacitance means I already said it is just opposite to the inductance. So V is replaced into the I place. Okay, V is replaced into I place is replaced into the V. That's all. So if you're going to replace, L is replaced into the C. So I is equal to C dot dV by dt. The next one, current equation of the inductance. I is equal to 1 by L integration V dot dt. Okay, similarly you have capacitance. Okay, that I is replaced into the V. Okay, V is replaced into the I. So these two similarity. Okay, that is a method to easy to remember. This is a final equation about the derivation of the L, C, capacitance. And then what is the power value of that inductance of Li squared of Cv squared. okay, of Li squared and of Cv squared. So these are the basic about the equation of a RLC. So let's we go ahead and further more of the basic terms. Okay, network elements. What are the basic network elements? There are 5 basic network elements. It is called. What are the 5? Active element and passive element. A network element, it will going to classify to 5. One is active element, passive element. The next one is a unilateral element, bilateral element. Next one is a linear element, non-linear element, lumped circuit, distributed circuit, time variant, time invariant. So like that, one network element is classified. Okay, first one, what is active element? Active element is nothing but simple to say teacher. Teacher is active element. Student is a passive element. What teacher? Why teacher? Teacher, it will going to delivering that content. So it is called a source. Source is a transforming. So see, voltage source, current source, that is called active element. Passive element means receiver, consumer, or LC. So these are the load. Okay, you can say load, or it is element. It will going to consume that one powers. So that's why it is called a passive element. Fine. So this is the difference between active element and a passive element. Unilateral element, bilateral element. So unilateral element means what I will going to say. It is called one-way directions. Only one way. Even you have see about in road also. Okay, one way they are mentioning. Okay, one-way directions. You should not come on opposite. Particularly, you have visit about the supermarket. Okay, high ranges of the supermarket. Okay, D-Mart. Okay, D-Mart, Reliance Mart. When you will go to visit there, actually that is one business concept behind. Okay, entry is one door, exit is another door. Entry is one door, exit is another door. That is about that they are doing. Why means that is one business secret is there. That one is explained by one of the film. Then only I am also coming to know that one. See, entry is one door. They never permit exit on the same door because the reason is that is a business secret. Business development, that is secret is nothing but the business development. So that is called unilateral. Unilateral means only one direction is permitted. Bilateral means both direction permitted. Okay, both direction it will going to permit. Okay, then next one, linear circuit, non-linear circuit. What is a linear circuit? Resistance, inductance, capacitance, these are the linear circuit. Non-linear circuit means power electronics devices such as diode, BJT, SCR. These are the non-linear circuit. What is a linear, non-linear? Okay, here voltage with respect to the time. Okay, you will going to linearly rise. Linearly, it will going to increase. That is a linear circuit. Non-linear means what? So voltage with respect to the time. Okay, your values it will going to vary. Increase, suddenly decrease, and increase, decrease, increase, decrease. So this is about okay non-linear, non-linear. Then lumped circuit, distributed circuit. What is a lumped circuit? Okay, it is a separable of the, you can say separable device. What is the resistance, inductance, capacitance? So these are the device you can call as a lumped circuit. Distributed circuit means distributed transformer. So the name is called easy to remember, distributed transformer. Okay, see the transformer. So why means interlayer? There use the transformer is the interlayer is used interwinding layer, or it is called interwinding. So capacitance of capacitor of a transformers. So that's why it is called a distributed. So example about that one. Next one, time variant, time invariant. What is a time variant? So sine waveform. Sine waveform. See that one. Okay, vary with respect to the time. So it will going to vary with respect to the time. Time invariant means based on the time, okay, the signal is not varied. So constant. If it is constant, means that is called time invariance. So these all are the types about that one network elements, circuit elements, basic of the network circuit element. Okay. Okay. So next one is a network detection technique. Network detection techniques means what? So network detection technique is nothing but I have the one large network is there. I want to make to compress. I need to compress. How to compress? So you should have the possibilities either the series. Okay, how many resistance is contained in series circuit or parallel circuit. Series circuit or parallel circuit. You need to find out. Okay, if it is a series circuit means okay, if you are going to use that formula, what is a series circuit and a parallel circuit? Okay, you are going to use the formula. Okay, or series and parallel combinations. So I will show you. See that once here you have the possibilities, say the resistance or the inductance or the capacitance. So these are possibilities. If the resistance is connected in seriously connected or resistance is connected in parallel. Similarly, inductance is connected in series or inductance is connected in parallel. Capacitance is connected in series or capacitance is connected in parallel. So this is about the possibilities. Okay, large number of the series connection circuit. So you will going to replace into the single one. See here. Okay, so 3 resistance is connected in series. I want to replace into that one single resistance. How to I will going to replace? The 3 is replaced into single. If it is a circuit is connected in series, addition. You will going to do the additions. First one, so resistance and inductance both equation is similar. So resistance and inductance is both equation you have, see both also addition, both also additions. So R1 plus R2 plus R3 additions. In similarly inductance are L1, L2, L3 additions. Okay. Okay. The next one, if it is a parallel means what you can say 1 by R equivalent. So the total resistance is nothing but this is called R equivalent. This is called R equivalent. So you need to find out the R equivalent of that one here. So how to you can find out what is the formula? 1 by R equivalent. 1 by R1 plus 1 by R2 plus 1 by R3. So you will going to substitute. Then after substitute you will going to get the answers, and then you can come as an R equivalent. I don't write about 1 by R equivalent. Here is R equivalent only you need to write. So what is R equivalent? You will going to find out and write the answers. Similarly, inductance also as similar. Okay, but when you have go for the capacitor, just it will going to reverse. Reverse means so series connected means use this formula. If it is a parallel connection of the capacitance means use this formula. What is this formula? Additions. So I add the C1, C2, C3. If it is that one here series connected 1 by C equivalent is equal to 1 by C1, 1 by C2, 1 by C3. So this is a basic formula used to you will going to find you will going to reduce the network. Okay, okay, large network is you will going to reduce into the single network. Okay, yes. If it is a 2 resistances parallel, you will going to use this only here 3 resistance. Suppose 2 resistance only parallel means what you will going to do? So remove these ones. So no resistance is there. Then 1 by R equivalent is equal to 1 by R1 plus 1 by R2. Or what is that one simple formula? R equivalent is equal to R equivalent it is equal to multiply divided by plus. Multiply here sorry multiply or product divided by plus. Okay, product divided by plus. What is the product? Product is a 2 resistance. What are the 2 resistance? R1 into R2 divided by R1 plus R2. That's all. R1 plus R2. So I already said, so inductance also same as it as similar to this one, similar to that one. So R is a replace into L, that's all. So product divided by summation. Product divided by summation. So in alphabetic order, okay, ABCD you can say P, Q, R, S. Why do I will going to say? So product, summations. Product is coming numerator, summation is coming on the denominator. So don't replace. Okay. So product is coming here. Product means this is the multiplications, and summation is the denominations. Fine. Okay. The next one more things I will going to teach you about the current division rule. Current division rule and voltage division rule. What is the current division rule and voltage division rule? I want to teach to you. Okay, see here I will going to draw one simple circuit. Okay, here I will going to draw. Okay, source followed by the resistance 1 and resistance 2. Okay, I will going to connect it. Okay, what is the source? Source is I will going to give about the 50 voltage. So 50 voltage. Resistance value I will going to give about that one 10 ohm and then 20 ohm I will going to give. 10 ohm and 20 ohm. So here across that one V1 and across to the V2. What it is say? V is equal to V1 plus V2. V1 plus V2. That's all. V is equal to V1 plus V2. Okay. So then what is the V2? Tell me fastly about V2. Tell me fastly about V2. Then use the formula. V2 is equal to what is the V? V is here. So first write this formula V. Okay, supply voltage V multiply. So what is across you want to find out? This one across you want to find out. What is that one? Ohm value 20 ohm. So 20 divided by divided by, okay, these two, sorry, first I want to write the formula. So R2, okay, so the R2 divided by R1 plus R2, R1 plus R2, here is formula is there, okay, R2 divided by R1 plus R2. So easy to remember, 2 2 2 2. If it is 1 means 1 1, that's all. Then now you can substitute what is the V value, 50. Then V 50 value will going to substitute 50, 20 divided by 20 plus 10, 30. Then that's all, very simple to, you will going to find the answers within the single. Otherwise you will going to make one more method is there, that is a complicated method too, you can find out what is the one more method. So V is equal to V1 plus V2. Okay, then how to, you can generally you can find out. So flow of the current you need to find out. What is the flow of the current? I is equal to what is the formula? Ohm's law. V is equal to I into R. V is equal to I into R. I is equal to what is the formula? V by R. V by R. What is the V value? V value is 50. Then R value, what is the R value? R means here the R equivalent. What is R value? Here two resistors are connected in series. If it is a two resistors are connected in series means you want to add. So 10 plus 20, 30. 10 plus 20, 30. So 50 divided by 30. Then this 50 divided by 30 is called the amps range. Now you found the amps range. Then you want to find out that one. What is that one? V2 across. You need to find out the, sorry, what you want to find out? V2 value you need to find out. Then what is the formula? Ohm's law. V is equal to I into R. I value do you know? Yes, I know I value. R value do you know? Yes, I know R value. Then substitute. Then I will go and write the equation. V2 is equal to I value. What is I value? 50 divided by 30. Okay, 0 0 cancel. Okay, then 5 by 3. 5 divided by 3. What is that one? R2. What is R2? 20. So that's all. See, I will go to, okay, one of the lengthy method replace into the simplest method. So that's why you will going to use the voltage division rule. Okay, current division rule. Current division rule, similarly you have seen that one flow of the current is I is common. Here is I1, I2 is divided. If it is I1 and I2 is, why it is divided? Because it's a parallel. Okay, then what is the flow of the current in I2? Can you find out? As similar to the formula. I2, do you want? Yes, I2 is equal to I2, it is equal to I into, as similar, V na, here I into R divided by, R only I am saying, R divided by, okay, what is in denomination? 2R is there, okay, R1 plus R2, R1 plus R2, okay, then here what is there? 2 is there, 2 is there, here 2 is there means 1 you will go and write, that's all. I2 means R1, see here I have written the formula, I2 is equal to I into R1 that way R1 plus R2. I into, see here 1 means here 2. So this is a formula you can use to simply, we are going to find out fastly about the current value of the I1 value, I2 value, similarly of the voltage V1 across the V1, V2. Okay, then yeah, we are going to coming to that one last point. Okay, circuit. In the circuit, see here I have show you one simple circuit. Branch. What is a branch? Branch means element. This element is called a branch. So what is the element? Either active element or a passive element. That is called a branch. Okay. See here, this is the one element. This is another element. This is another element. This is another element. This is another element. Okay. Here the two element is connected. Okay, seriously connected. So this is called a branch. You can say AB. AB is a branch. AE is a branch. BC is a branch. CD is a branch. DE is a branch. This is called a branch. Okay. The next one, junction. What is a junction? You can call it junction. Junction point. You can come to the junction means 3 roads. So in our road, okay, 3 road and more than 3 roads joining point. That is called a junction. So 3 roads, 4 roads joining point is called a junction. Okay, so junction means what is a junction? Okay, 3 roads. Okay, more than 3 roads. Okay, 3 road joining point is called a junction. 3 road or 4 road or 5 roads. So joining point is called a junction. So coming to that one, here is a similar. Okay, the more than 3 and more than 3 of the elements joining point. Element okay, joining point or node joining point. Okay, here is a more than 3 elements where, so 1, 2 and 3. So this is about, you can call about that junction. You can call about that one. 3 points is called connected. 1, 2, 3. 3 point is connected. So E and C is a 3 point is connected. What about B? B is a two element is connecting point. So two and above is connecting point is called a node. Two and above element is connecting point is called a node. This is called a node. This is called a node. This is called a two and above element is connecting is called a node. Okay, three and above element is connected is called a junction point. Junction point, or another name is called a principal node. So junction point, or you can call it about the principal node. What is a principal node? Okay, three roads, easy to remember. Principal node or junction point, three roads, four roads, or more than three roads joining point. Okay, what is a node? Node means node means what is a two element joining point. Two element, okay, two and above. So two and above elements is joining point. So A is element, two element joining point. So two element is joining point. A, B, C, more than two. C, D, E. So these are the node. Okay. So two element joining point is called a simple node, you can say. The next one is you can mesh loop. What is a mesh loop? Means closed path of the circuits. So closed path of the network or circuit is called a mesh and a loop. So A, B, C, E is one loop, and E, C, D is another loop. Okay, fine. Next, what you will going to learn about that one means in that one Kirchhoff's law you will going to learn. Okay, Kirchhoff's law followed by analysis. You will going to learn about the analysis. What are the analysis you have? You have means one is a nodal analysis, node analysis. Second one is a mesh analysis, node analysis, mesh analysis. There, what is a node analysis means Kirchhoff current law. Mesh analysis means Kirchhoff voltage law plus Ohm's law plus Ohm's law. That's all. So node analysis means node Kirchhoff current law plus Ohm's law. Mesh analysis means Kirchhoff voltage law plus Ohm's law. That's all. Okay. So you will going to complete about node analysis and mesh analysis. And further it is there super node. What is a super node and super mesh? So as similar to you will going to work on that one. Super node means first you want to know what it is called a super node in your given circuit. Okay, is it called a super node or not? You want to find out. How to find out? See that this is a node point 1 and node point 2. Node point 1 and node point 2. Between the two node, voltage source is present, means that is called a super node. Between the two node, okay, voltage source is present. See here, okay, between the two nodes, A and E is a node. Okay, if A and E is between that one, what is there? Voltage source is present. Voltage source is present. So between the two node, A and E is a two node. Between the two node, what is there? If voltage source is present, means that is called a super node. Okay, then next one, what is a super mesh? See, here is a one loop. Yes, this is a one loop. This is another loop. Okay, does this circuit is a super mesh? No. Why it is not super mesh? Between the two loop, okay, see here there is a two loop is there. It's commonly any current source is present. See here commonly what is there? One resistance is there. So current source are intersecting the loop. See this resistance is I am going to replace into that one current source is there, means if the resistance is replaced into the one current source is there, means that is called as a super mesh. That's all. That is called a super mesh. What is a super mesh? Loop. Okay, super mesh means it is a two loop. In the circuit is a two loop is there. In the two loop commonly any current source is there. Between two nodes, voltage source for that node, current source for that mesh. That's all. So one more easy to understand, easy to remember. You see Kirchhoff current law for node, but super node when you coming voltage just opposite. Between two node, voltage source is present. Mesh analysis, Kirchhoff voltage law in that one, but here loop is there. Between that one, voltage is the opposite, current is present. So like you will going to keep in your mind, easy to understand. Super node, super mesh. Node means voltage, mesh means current. Okay, node. So between the two, two node. So another one more easy to remember. Node means node. This is a node point. Between the two node, voltage source is present. Mesh means between the two loop. Mesh means already we have seen loop. So I already say it is a closed path loop. So mesh means loop. So between the two loop, what is that? Current source is present, means that is about the super mesh. So that's all about the first part is over. So next part we'll go on to see about the Kirchhoff's law and node analysis, mesh analysis.